basically going to build a interactive way to do an art installation or to do live music performance and have everything sync up wirelessly and not break on you. So I'll just walk through the pieces I have laying out. The first piece is a Raspberry Pi. It's just a small Linux computer. And then I have Raspbian installed on one of these micro SDs. I have a case for it. And then I have an infrared camera, which I'm not going to use now, but I'm going to set it up anyways. And then I also have my micro or tiny USB, and then a fairly strong power supply. This one does 1 amp. You want to generally at least have that. To give you an example of the sort of wireless controls you would do for an art installation, this is a wireless guitar wah pedal that uses OSC to control guitar effects in Ableton Live. We'll walk through and do this one and show how to set this up for this. But generally speaking, all you need is this XBee X-Stick by Digi. That's going to give us wireless communication to any sort of like Arduino type devices you're going to build and add together. And then yeah, the Raspberry Pi will basically just be the center that sends back all of our OSC into our live performance computer. So we'll just walk through it. Put together your Raspberry Pi. If you look at it, it's got a few markers that let you know where things go. This is the top and this is the bottom. Your memory card is obviously going to go in the bottom, but let's start out by putting a Raspberry Pi in the case. So first thing to align is your USB. Goes in like that, and there's a little bit of pressure here. You might need to not break it, but get it in there snug. Helps to do that way. And then the other thing is this infrared camera I talked about earlier. I'm going to put this in here. Goes in this little slot here, and it goes facing this way. It's got a little thing that you pop up, you pull on the sides, and it pops up, and then you push it down. So I'm going to do it, but it's going to be a bit of a craziness because this case doesn't have enough room for it. So thread it through first, and then push it on, and push it in. So it should clip in. It should go all the way in. It should be tight like that. And then that's basically the only tricky thing to do to get this case together. And then it just snaps right in. You can see we've got the infrared camera dangling out in the middle of nowhere, not mounted anywhere. And then finally, we have our micro SD. I already put Linux on this. It's got Raspbian downloaded from the Raspberry Pi website. The power supply from this just comes from the micro USB, and you just plug it in. Make sure you got it the right way around. So that's it. It's ready to be plugged in. And for this, we're going to have an XBee X-Stick, and we're going to plug it into Ethernet. So we're not going to do any sort of Wi-Fi dongle or anything. So I'm going to plug it in, and then I'm going to SSH into it. So I kind of skipped over this before, but the Raspberry Pi is always going to be connected via Ethernet. Whenever you do any sort of interactive or live thing, you want to have as much stuff be wired via Ethernet as possible. When you come to a place like New York City, you're going to have a lot of Wi-Fi interference basically, and you can have things go up, go down, and break, and you don't want to have that happen just because you're in a bad Wi-Fi reception room. So the Raspberry Pi is always going to be wired up. That being said, all of our controls happening wirelessly are going to be happening via XBee. XBee works on the same radio frequency wavelength as Wi-Fi, but it's has way bigger range and is way more powerful and is way more reliable. I think if you get the XBee Pros, you can go up to 1.5 miles line of sight. So it's really a lot more powerful and further distance than just straight up Wi-Fi. And I found it to be pretty damn solid in general. And goes pretty good travel distance through concrete walls or whatever may be in the way or interfering at your performance or art installation or whatever. So yeah, that's the way. XBee for any sort of radio communications, and then just a router and Ethernet cables directly into anything talking, either OSC, MIDI, whatever. So the first thing we're going to do is SSH into our Raspberry Pi that's connected to Ethernet. So I'm going to open up Terminal. And then the default username is Pi, and then my IP address. And then the password should be Raspberry. So it hasn't been configured yet, so we'll start by doing that. And if you press tab, it should automatically complete for you. Let's do that. File system been resized, change the password. Alright, we can keep it for now. It's not connected to anything. Let's make it so it just goes to console. Yeah. And enable it to work with the camera. Enable. We're not going to use that now, but I need to have that anyways. Let's see what's in advanced. Host name. Enable, disable, SSH. We're not going to use audio either, so let's just go back and finish and reboot it. So right now it's rebooting, and we'll see what's up with it in a second. Alright, so our Raspberry Pi just finished restarting, so let's SSH back into it. Type in our password properly. And then we can do an ls USB to make sure that we have it. And so now your digi is going to show up as this, FTDI. If you look at the first initials, FTDI, that's just the serial driver that is on the X stick. And so that lets us know that Linux has seen it and it's device 004. So now let's try doing an IPython session. Oh, we don't have it. So since we don't have it, let's try doing an app get and install Python. And so now, if it doesn't make sense to you, right now I'm just connecting to the Raspberry Pi from another computer. I'm not actually using the Raspberry Pi's video monitor for anything right now. If you look at my machine, you can tell I'm on a Mac machine. And so now we're letting everything download, get installed. And so the reason I'm installing IPython is so that we can walk through getting serial data on our X stick to make sure that it's actually working and we know where it is and how to talk to it. XBee X sticks are configured by plugging them in. Well, we'll just jump into it. So let's do IPython now, and let's see if we have serial by default. If not, we'll have to install that too. So let's go import serial. Alright, so we have it. And so over here I have an article open about getting Raspberry Pi set up with Python. This is just the quickest way to figure out what is going on. So we have our import serial. So let's do the next piece. So the serial dot serial, and you can see we have tab complete here. TTY USB 0. So that's the first USB device. And we're going to set the baud rate to 9600. Alright, so let's set our string to be hello from interactive world. And then we can do a seer.write. And as I press tab, you can see I get all the functions that are available. So I can get DSR, get CTS, a bunch of stuff. I have no idea what it does. So .write, and also this is a good time to point out, if I press question mark, I'm going to actually get information on how it works. So this, if I press seer, let's see what happens. So this is our serial object, and it initializes a COM port object. So it should be open because if we read here, it says the port will be open immediately. So let's go back and see here our seer.write is our first thing next. So let's try that. Seer.write. And then again with a question mark, you see it just outputs the given string over the serial port. So seer.write, and then let's try our string with this. So %s just says the string variable that's after this, and this /n is like the computer's way of knowing new line. So, and then string. So let's see if that works. Alright, so we got back 30. So let's see what that means. What gets returned? Ah, the length of the data. So when we got that 30 back, that's the length of the data that was sent out. So if you see here, when I did the double question mark, I asked for the actual source code for the write. So you can see the seer.write is just a function that's defined, and its write takes itself, which is the seer object we have, this seer, and then the data to write to it. And so we sent that string of, what was our string? I believe it was hello from the interactive world. And that string was 30 long, 30 characters long. So we successfully wrote that. If I had another XBee device connected here, we would have seen that here. So we'll move on to the next bit, and we'll set this up as our media center point. And so to get a little bit further into this IPython console, I have this serial object here that we initialized, and remember we started it by saying import serial, right? And then we did this seer equals serial dot serial with our USB device. Remember /dev/tty USB 0. And the capitalization matters here. And then this 9600, right? So this 9600 says we're at 9600 baud, or 9600 baud rate. This is really important with serial communications. You always want to make sure you have the right set of things. So if you're reading at 9600 or you're writing at 9600, you want all of your devices to be at 9600, otherwise things can get mangled in between. So yeah, next we'll set this up as a device to start getting messages from other XBee devices. So to close out the IPython session, we just hit exit with the open and close parentheses. And so now I'm going to get things set up over here, and I'm going to install my other XBee device.